We all kind of walk around with these basic assumptions about being alive. A set of unwritten rules that are so fundamental, we don't even notice them. We just take them for granted, because for most of us, they work. They're the quiet background noise to our entire biological existence.
Okay, so let's get into this. These are the bedrock principles, right? Pain is our built-in alarm system. Sleep is how we reboot. And our bodies, well, they're supposed to do what our minds tell them to. This is the version of human that you read about in a textbook, but it's not the only version out there.
Because here's the thing about biology. It doesn't actually follow rigid rules. It's all about probabilities. It's this incredibly delicate and complex process. And sometimes, just sometimes, those probabilities break down. The system fails. And in those moments, we get this incredible glimpse into a version of being alive that is pushed to the absolute edge of what is biologically possible.
So a life anomaly, it isn't just some rare disease. It's something way more fundamental than that. It's a deviation so profound that it challenges our deepest intuitions about what it means to be alive. These conditions show us that the systems we rely on the most, feeling pain, having a predictable body plan, even our own sense of self, they're not guarantees. They're fragile, and they show us just how much precision it takes to create what we call normal.
All right, so let's start with one of the most basic safeguards we have: sensation. What happens when the world just stops sending you danger signals? This first section is all about what happens when our very perception of reality gets fundamentally scrambled.
I mean, can you even imagine growing up unable to feel pain? Not as a superpower, but as a neurological reality. A broken bone that just feels like a weird pressure. A serious burn that doesn't set off a single alarm bell in your brain. This is the world for someone with SIPA. It's a profound absence, right at the body's most basic level of self-protection.
And this right here, this is what's so fascinating. It completely flips our perspective. We're all conditioned to think of pain as the bad guy, something to get rid of. But SIPA demonstrates so clearly what pain's real job is. It's not the enemy at all. It's critical survival information. And when it's gone, it doesn't feel like a gift. It turns every little interaction with the world into a potential hazard you can't even see.
So, how on earth does this happen? Well, it all comes down to a tiny mutation in a single gene. That one change prevents the body from ever developing the specific nerve fibers that are supposed to carry pain and temperature signals to the brain. Those warning messages just never get sent. And what's wild is how specific it is. The nerves for pressure and touch, they work just fine. But that same genetic pathway also controls sweating, so the body can't cool itself down, which is a huge problem. The result is a lifetime of silent damage, repeated fractures, burns, infections, all because the body's alarm system is permanently offline.
And we are talking about something that is extraordinarily rare. We're estimating maybe 1 in a million people worldwide. That rarity makes it really easy to just dismiss it as a medical curiosity, but for the people who actually live with it, their reality is this constant, exhausting effort to be their own external alarm system, always on the lookout for harm their bodies can't warn them about.
Okay, so let's build on that. We've talked about a failed signal, now let's talk about a failed blueprint. Human development is this mind-bogglingly precise cascade of instructions unfolding over weeks. But what happens when that cascade gets disrupted? Right at the very beginning?
Cyanomelia is one of the most severe disruptions you can imagine in that developmental process. An infant is born with their lower limbs formed into a single structure. And this almost always comes with catastrophic problems with internal organs, like the kidneys. Now, it's really important to understand this isn't two normal legs that somehow got fused together. The limb structures themselves just develop abnormally from the get-go.
And this just brilliantly illustrates how early and how permanent these things are. Some critical disruption happens in the first few weeks of embryonic life, often before pregnancy is even known. And this one event, likely tied to blood supply, basically starves the lower half of the body of the resources it needs. The body's entire architecture is permanently redrawn before the baby is even born.
You know what's really interesting here, though? Science still isn't 100% sure why it happens. The leading theory is something called the vascular steal hypothesis. Basically, that abnormal blood flow steals circulation away from the lower body. But that's not settled science. There are other ideas. The fact that we're still debating the exact cause just shows how much of our own development is still a total puzzle.
So to put this all in perspective, let's just look at the numbers. While SIPA is exceptionally rare, cyromelia happens in about 1 in every 100,000 births. Still incredibly uncommon, for sure. But this comparison helps ground these abstract ideas in a bit of statistical reality. Every single case is a profound departure from the biological norm.
So the main point here isn't just the shocking anatomy of Sirene Amelia. It's what the condition tells us about our own development. It really drives home how much of our final shape, 2 arms, 2 legs, organs that work, depends entirely on this intricate, perfectly timed sequence of signals that are firing off in the dark in the very earliest moments of our existence. Okay, so let's tie this all together. We've looked at a failure of sensation and a failure of the body's blueprint. Each of these anomalies takes a basic assumption we have about being human and just shatters it. They're not just isolated medical events. They force us to go back and rewrite those unwritten rules we started with.
This table really brings it all home. We started out with pain protects us, while SEPA proves that pain is just a signal, and that signal can pale. We assumed development follows a predictable plan. Sirene Amelia shows that it's a process that can dramatically diverge. And these are just 2 examples. Other anomalies challenge even more fundamental rules. Things like alien hand syndrome can literally disconnect our will from our actions, and Cotard syndrome can fracture our very sense of being alive. Each one reveals another crack in the foundation of what we assume is solid reality.
So here's the most important point. There's a tendency to look at these conditions as medical curiosities, as spectacles, and that's a huge mistake. The better way, the more useful way to see them is as powerful reminders. They remind us that life isn't a fixed design. It's an ongoing process built piece by piece through countless delicate biological moments, and any one of them can shift, revealing just how extraordinary normal really is.
And that brings us to the final thought. For most of us, our bodies work so well that we don't even see the complexity. It's invisible. These rare anomalies pull back that curtain. They show us that biology never promises certainty, it just produces it, most of the time. And when it doesn't, the result isn't something alien, it's still human life, just a life lived at the very, very edge of what our biology can sustain. And what does that tell us about the nature of being human itself?